We continue with exercise 13.3. Up to 9th question we did in the previous session. Now we'll go for question number 10. Again, it is based on Bayes rule. If you read the question, somewhere you will see that she obtained exactly one head. That means that event has occurred. So here we define the event A. What is the definition of event A? This event of getting, you see, event of getting what? Exactly what? One head. That is event A. That event has already occurred. Now you must have those two events, E1 and E2. How do you define E1 and E2? That is connected with question. So E1 and E2. Okay. What is the probability that she threw 1, 2, 3 or 5 with the die? Okay, so this is event that outcome is here. Outcome is either 1, 2, 3 or 4, and this is event that the outcome is the other one is what, either 5 or 6. So you can write these two probabilities of E1 plus the probability of E2, and the summation should be exactly 1. Now what's the probability of event E1? So here what's the probability of getting 1, 2, 3 or 5? That is nothing but the 4 by 6. And what's the probability of getting 5 or 6, which is 2 by 6? So you can see that this summation is exactly 1. Fine. Now once we have the event A, therefore we have these two conditional probabilities. Which two conditional probabilities here? Probability of A given the event E1 and the probability of A given the event E2. Fine? Okay. Now what is the meaning of this event E1 has occurred? That means outcomes are 1, 2, 3 and 4 or 5. Then what she will do? She tosses a coin once. So what is the probability of getting one head if coin is tossed once, which is 1 by 2? Fine. So I repeat this. See. What's the meaning of this? This means event E1 has occurred. Event has occurred, that means either you obtain 1, 2, 3 or 5. Then she tosses a coin once. So what's the probability of getting one head in a throw of coin? That is nothing but what? 1 by 2. That's obvious here. Okay, chalo, now come to this next event. What's the next event here? That's the probability of event A over E2. Fine. E2 has occurred. E2 has occurred means what? It means either 5 or 6 is obtained. Okay, then what she will do? She tosses a coin 3 times and noted the number of heads. She notes the number of heads. That is nothing but which event? The event E2. Okay, so in that case, if you list out all the outcomes and if you count the number of heads here in this case, so these are the outcomes if coin is tossed 3 times. We know it, right? I'm just listing for your information. We know it. Let me list here so you will see. This is HTT, then THT, then here you have TTH and all are tails, right? This will occur after the occurrence of E2. Just read the question, you will realize. Now out of this here, how many outcomes are having exactly one H? So 1, 2 and 3. Total is 8. So here probability is 3 by 8. Fine. This is for this event. I repeat this. Event E2 has already occurred. That means either the outcome is 5 or 6. Then what we'll do? We throw a coin 3 times. So these are the outcomes 8. Among these 8, there are 3 outcomes there, exactly 1 head is obtained. So we have 3 by 8. Fine? Okay. So now just let's read the question. So you can answer the required probability equals to, please read the question. Event A has already occurred. She has already obtained exactly 1 head. So event A has occurred. Then what is the probability that she threw 1, 2, 3 or 5? That is the probability of occurrence of even. Now you can answer this by Bayes rule. So by Bayes rule, let's answer. So this is P of even into P of A over even upon, just write that expression, that is P of even into P of A over even plus P of E2 into P of A over E2. Let's place the value here. What is P of even? That is this one, 4 by 6, which is 2 by 3, into conditional probability, which is 1 by 2, upon the same 2 by 3 into 1 by 2 plus P of E2. What is P of E2? That is 1 by 3 here. So 1 by 3 into this is 3 by 8. Let's simplify this. So after the simplification, you will get the required probability. That is here how much? 8 by 11. Please do this much calculation, you will get this. Question number 11. If you read the question, you will see that one event has occurred. Which event? That a defective item is produced. So that is our definition of event A. That is, your item is defective. Item is defective. That event has occurred. Now, what's the question? That what is the probability that it was produced by A? So that is your definition of event E1. That is, it is produced by A. There are 3 events here. Then produced by B, and here E3, that is produced by C. So therefore the probability of E1, how much percentage is produced by A? That is, you read the question, you will see that the 50%. So 50 by 100. Okay, so you can just write 5 by 10, or you can write 1 by 2 also. Produced by 2, how much? You are given 30%, 30 by 100. So you can just write 3 by 10. And how much produced by third one? That is C, which is event E3, which is 20 by 100. So you can just write 2 by 10. You can notice that 2 by 10, 3 by 10 and 5 by 10. The summation is exactly 1. It has to be 1 because events forms the partition. We know it very well. Okay. Now we have these 3 conditional probabilities. Therefore, probability of the occurrence of even and A here. What is this? Event even has occurred. So produced by A and then it is defective. How much percentage is produced by A and defective? You are given here 1%. So 1 by 100. Probability of occurrence of E2, that is produced by machine B and then it is defective. What's that defective percentage? That will be 5%, so 5 by 100. Then third conditional probability. Here E3, that is produced by third machine and then it is defective, which is how much? 7%, so 7 by 100. Now, therefore, the required probability equals to, which event has already occurred? The event A has already occurred. And then what's the probability that it is produced by A? That is occurrence of E1. So by Bayes rule, you have P of E1 into probability of A over E1 plus here P of E2 into probability of A over E2 plus P of E3 into probability of A over E3, and here the same term P of E1 into P of A over E1. Now we are just placing the values. let's place the values. So here P of even 5 by 10, conditional probability 1 by 100. This is 5 by 10 into 1 by 100 plus E2. What is E2? That is 3 by 10 into A over E2, which is 5 by 10. Plus, what about the last one? That is here 2 by 10 into A over E3, which is 7 by 100. So we have this. So you can see that this 1000 will get cancelled from both. We have 5 upon here 5 plus 15 plus 14. So from this you will have here 5 upon how much? This 34. This is required probability here. Question number 12. A card from a pack of 52 cards is lost. From the remaining cards of the pack, 2 cards are drawn and are found to be both diamonds. Okay, so that event has occurred. So that is the definition of event A. So I'll write that in event A. What is event A? That is both cards are of diamonds, because this event has occurred. Okay, now 2 events are connected with this. We call them as event E1 and E2. Okay, now what is definition of event E1? That is connected with the question. What is the question? Find the probability that the lost card being a diamond. So how do we define event here? That's the event that the lost card is a diamond, an event that the card is of not diamond, event that lost card is of diamond, and this is event that lost card is not a diamond. That is nothing but the event E2. Fine. Now here, therefore you can write the probability of E1 and probability of E2. What is even? That the lost card is of diamond. How many diamonds cards are there? We know 13. So one card is lost, that is of diamond. So one diamond card, 13 by 52, which is, we know, just 1 by 4. Probability of the event E2, not of diamond, that is just complementary event, remaining 39 cards out of 52 cards. So we will have here just 3 by 4. 3 by 4 plus 1 by 4, which is 1. Complementary events. Okay, now we just consider this conditional probability. Now probability of the event A given the event E1. The event E1 has occurred. Event E1 has occurred means what? That the lost card is of diamond. Okay. Now we are going to select how many cards? Diamonds cards, but 2 diamonds cards. Both the cards are diamonds. Now event even has occurred, that means 1 card is already we have lost. So we are left with 12 and you are going to select any 2 from this. So 12 C2. Total cards will be how many now? 51. So 51 C2. I hope this is clear to you. What's the meaning of this? If you just emphasize here, you will realize event E1 has occurred. That is 1 card lost which is of diamond. So total you are left with 12. You are going to select 2 from there. So 12 C2. Total 51, 2 favorable. So 51 C2. Let's simplify this. So here 12 factorial upon 10 factorial into 2 factorial. The whole upon 51 factorial upon 51 minus 2, which is 49 factorial into 2 factorial. So we'll just simplify. If we simplify this, you know here this is equals to, this is 12 into 11, that 10 factorial will cancel upon 2, the whole upon, this is 51 into 50, and then that 49 factorial will cancel upon 2. So this 2 again will get cancelled, and finally we are getting 12 into 11 upon 51 into 50. So again that half will get cancelled. So this is 6 and this is just here 25. So if we simplify, we'll get the 22 11 into 2, because this is just left with 6, and upon 4 25. That's this conditional probability. Now we go to second one. Now which second probability? That is probability of the event A given the event E2. So E2 has already occurred. That is, that lost card is not of diamond. Lost card is not of diamond, remember. So how many diamonds cards are there? 13. You are going to select any two from them. So these are the favorable outcomes. One card we already lost, remember. So total number of cards will be how many now? 51. So here it is 51 C2. You must have realized why 12 here, because here that lost card is of diamond and you are selecting two diamond cards. Here the card is lost but which is not of diamond. So now let's simplify. So this is 13 factorial upon 13 minus 2, 11 factorial into 2 factorial upon 51 factorial upon 49 factorial into 2 factorial. So now further simplification gives us, finally you just simplify as I did there, you will get the 26 by 425. How do you simplify? 13 into 12, then 11 factorial will get cancelled. 51 into, as I did here, 50, 49 will get cancelled. This 2 factorial will get cancelled and simplify. So we'll have this. Okay, now we just come to the question. So let's come to the question. So required probability equals to, what was the question? Let's read the question. The question was here, both are diamonds. So event A has occurred. Then what is the probability that the lost card being diamond? Which event you had called as the lost card is diamond? That is even. So you want this probability of even given the event A. Now we just write formula for this. We know formula. We have written it number of times. So P of here even into P of A over even upon P of even into P of A over even plus P of E2 into P of A over E2. Just put the values. If I just put the values here, 1 by 4 into, what is this conditional probability? 22 by 425 upon your 1 by 4 into 22 by 425 plus what about this? 3 by 4 into, what is this? 26 by 425. So just simplify. So you will get the required probability here. The question is now just simplification. For the 13th MCQ, let's read the question. Probability that A speaks truth is 4 by 5. A coin is tossed. Reports that a head appears. So that event has occurred. So what is event A here? That is head appears. That is event A. Okay. Now we have here two connected events. One is even. What is definition of event even? That is A speaks truth. So let A be an event that A speaks truth. And what is E2? That is event that A doesn't speak truth, that is A lies. And therefore probability of E1 you are given 4 by 5, and probability of E2, that is 1 minus 4 by 5, that is just 1 by 5. These two events are actually complementary events. Fine. What is the event? Event that is A speaks truth. E2, that is a complementary event. A doesn't speak truth, that is A lies. Okay. This is 4 by 5, this is 1 by 5. You can see that this summation is 1. Okay. And now this event A. So therefore probability of A given the event E1, probability of A given the event E2. Okay. Now what about this two? Event E1 has occurred, that means speaks truth. And then what's the probability that head appears? In a single throw, probability is always 1 by 2 of getting H. Fine. Now what's the meaning of this? E2 has already occurred, that means A doesn't speak truth, that is A lies. Then what's the probability of getting head, which is again 1 by 2. Actually this 1 by 2 is independent of this event A, E1 and E2. Whether A speaks truth or speaks lies, the probability of getting H in a single throw of a coin is always 1 by 2. So these both are always 1 by 2. It is independent of E1 and E2. Okay, now come to the question. What is the required probability here? Required probability equals to, what's that probability? That event A has occurred, that is speaks truth. Sorry, event A is head appears. Event A is what? Head appears. And what is the question? The question is here that says that probability that actually there was head, that means it speaks truth, that is the probability of E1. I repeat this, why like this? See, event A has already occurred, that is head appears. What is E1 here? That based on the question, probability that actually there was head. Actually there was head means what? That A speaks truth. Is it? So required probability is the probability of the event that A speaks truth given that head appears. Head appears and actually there was a head. That means A speaks truth. That's why we have this. Now we just use the result. This is A over E1 into probability of E1 upon P of E1 into probability of A over E1 plus P of E2 into probability of A over E2. Let's place the value here. E1, that is 4 by 5 here, into 1 by 2 upon 4 by 5 into 1 by 2 plus what is P of E2, that is 1 by 5 into 1 by 2. So this 1 by 2 you can take common and it will get cancelled. 5 will get cancelled. So here you are left with 4 and this is plus 1. So this is 5. So we are getting finally how much? 4 by 5. And that is nothing but the option A. Let's see now last MCQ. We are given for two events, A is a subset of B. Therefore, you can write A intersection B equals to A. And therefore, probability of A intersection B equals to P of A. Okay, now you can just try by trial and error from the options. And also you can write from this directly that P of A is less than or equal to P of B. So you have inequality in the question. So it's obvious that either the option B must be true or option C must be true because you have inequality here. Now if you try for option B, there you have this conditional probability less than P of A. Now what is this? This is A intersection B upon P of B is less than P of A. So from this, this is just P of A here. you can just place P of A. So P of A will get cancelled, you take on the other side. So probability of the event B is more than 1. This is not possible. Not possible. Fine. So here on this side, now it has to be option C. Let's see this. Over here, you are given this is greater than or equal to P of A. What is this? A intersection B upon P of B is greater than or equal to P of A. Place the value here. What is this? This is P of B. This is P of A. So this will get cancelled. So from this, here you have just 1 greater than or equal to P of A. And this is always true. Probability of event A is always less than or equal to 1. Let's see last 14th MCQ. We are given the one is A is a subset of B. So from this you can write A intersection B equals to A, smaller event. This means probability of A should be less than or equal to probability of B. And from this, probability of A intersection B equals to probability of A. We have these two things. From the first condition here, it's quite obvious that either you have option B or C, because there you have inequality, or D if both of them are not true. So let's go for option B. There left hand side you have conditional probability. So I'll use the result. You know P of A over B is this upon P of B is less than P of A. I have just written option B. Now what is this? P of A intersection B, that is just P of A. So this will get cancelled. You will get the 1 upon P of B less than 1. So if I take on the other side, you have this probability of B greater than A. This is not possible. Probability, we know that it never exceeds 1. So now what about the option B? It is just, you can see the reverse of this. So if you start with this option C, you will see that there you will get the probability of B greater than or equal to 1, which is always true. And therefore C is your option.